In this lesson, we'll look at adding and subtracting linear expressions. Remember, a linear expression is just an algebraic expression that can only be raised to the power of 1. The sticky note on the slide tells us exactly what we need to do in order to add or subtract linear expressions. First, it says to change any subtraction to add the opposite. You don't have to do this, but I personally prefer to do this. It helps me to avoid mistakes when adding and subtracting with positive and negative numbers, and when distributing a negative over parentheses. If there are any coefficients out in front of parentheses, you'll use the distributive property to multiply each of the terms inside of parentheses by that coefficient first. Then rewrite without parentheses, using the commutative property of addition to regroup like terms. And then finally combine those like terms to simplify the expression. So in the first example, we do have a subtraction, so I'll go ahead and change x minus 2 to x plus negative 2. There's nothing to distribute, so I'll rewrite without parentheses, and I'll group like terms next to each other at the same time. I can see here that we have x and 3x and negative 2 and 8. Those are like terms because they have the same variable raised to the same power. Whenever you're writing an expression, simplifying an expression that includes variables, the variable that is raised to the highest power comes first, and then it decreases until you have a number without any variable. So here we have x plus 3x plus negative 2 plus 8. I can keep the negative number in parentheses. When it says to get rid of parentheses, it's just talking about having something to solve inside of parentheses. And now we can go ahead and solve by combining like terms. X plus 3x is just 1x plus 3x, so that's a total of 4x plus, and then negative 2 plus 8 is positive 6. Don't forget, you have to continue to use the rules for adding and subtracting and multiplying and dividing positive and negative numbers when simplifying these expressions. Here we have some subtraction, so I'll change that to add the opposite first. I do see that we have a coefficient out in front of parentheses, so I'll also distribute the 2 over parentheses. That means that we will multiply the 2 by each of the terms inside of parentheses before we rewrite this problem. 2 times negative 7 and 5/10 z is equal to negative 15z. Remember, a positive times a negative is a negative. Plus 2 times 3 is 6, plus 5z plus negative 2. Find like terms. Negative 15z and 5z have the same variable raised to the same power, and 6 and negative 2 do not have variables at all. Negative 15z plus 5z plus 6 plus negative 2. We've just used the commutative property to group like terms, and we'll solve. Negative 15z plus 5z is negative 10z, plus 6 plus negative 2 is 4. One more addition problem. There is some subtraction that I'll change to add the opposite, and there are some numbers out in front of parentheses that I will distribute. So first I'll show that we'll multiply 1/2 by w and add that to 1/2 times negative 6. We'll do the same thing for the second expression. We'll multiply 1/4 times w and 1/4 times 12. 1/2 times w is 1/2 w plus 1/2 times negative 6. I know a positive times a negative is a negative, and half of 6 is 3, so this would be negative 3, plus 1/4 times w is just 1/4 w, and 1/4 times 12 is the same thing as saying take 12 and break it into 4 equal size groups for a total of 3. Find like terms. 1/2 w and 1/4 w have the same variable raised to the same power, and negative 3 and 3 do not have variables at all. 1/2 w plus 1/4 w plus -3 plus 3. Now, I do still need to follow the rules for adding and subtracting fractions. So 1/2 and 1/4 w need a common denominator. I know that 1/2 is the same thing as 2/4. So when I rewrite this, I can actually just put next to that this is the same thing as 2/4. If it can be solved mentally, go ahead and do that. So 2/4 plus 1/4 is 3/4 w. And I also see that I'm adding -3 plus 3 on the end here. Not sure why I had that in parentheses, but I did. -3 and 3 are opposites. Opposites when added together equal 0. So here I'm adding 0. You do not need to show the plus 0 on the end. So if you want to write it, then to simplify it even further, that's fine. Or you can just avoid writing that plus 0 on the end right from the start. The steps for subtracting linear expressions are exactly the same, except you'll always have some subtraction to change to add the opposite. When there is a subtraction sign, I always prefer to write a coefficient for the parentheses that follow. So for example, here we've got 5x plus 6 minus the sum of -x plus 6. When there is no coefficient in front to distribute, we actually have a 1, a coefficient of 1. When I put that in there, it helps me personally when I do add the opposite, so that I'm distributing a -1 over parentheses. It helps me to determine what we get when we multiply by that negative sign. So here we've got 5x plus 6 plus, and now I've got -1 times -x, and this is why I like to have the -1 there and not just a negative sign. A negative times a negative is a positive, and 1 times any number or variable will just give you back that number or variable. So -1 times -x is actually going to be just a positive x. And then -1 times 6, a positive times a negative is a negative, so this would be -6. Find like terms. 5x and x are the same variable raised to the same power, and 6 and -6 both are lacking variables. So we've got 5x plus x plus 6 plus -6. This is another example where I've got those opposites on the end, so in this instance, I'm not going to write plus 0. 5x plus x is just 6x. So here we've got another example of subtraction. This one does have a coefficient to distribute, so we don't have to insert the 1. I'll change the subtraction to add the opposite, and then I'll also change it to add the opposite within parentheses at the end. Now we'll distribute. -2 times 4y would be -8y plus -2 times -3. Negative times a negative is a positive, 6. Find like terms. I actually do not need these parentheses. So we've got 7y and -8y, same variable raised to the same power, and 5 and 6. 7y plus -8y plus 5 plus 6, and combine. 7y plus -8y is -1y. Typically, if the coefficient is 1, we don't write it, so this would just be -y plus 11. One more example with subtraction. Add the opposite, add the opposite. There's no coefficient, so I'm going to put a 1 there. Add, oh, excuse me, that is not addition. That is a negative, and there we have it. Now we can go ahead and distribute. M plus -3 has nothing to distribute. The next one, we've got -1 times -m. A negative times a negative is a positive, so this is actually just going to be a positive m. Plus, and then -1 times 12 is -12. Find your like terms, m and m. negative 3 and negative 12. This would be m plus negative 3 plus negative 12. M plus m is 2m, and negative 3 plus negative 12 is negative 15. This can be written as 2m plus negative 15 or 2m minus 15. Those are the exact same solution, and you will on occasion see them written both ways. And the last problem is a real-life problem for some people. It says that the original price of a hat is $D. You use a coupon and buy the hat for D minus $2. You decorate the hat and sell it for 2D minus $4. Write an expression that represents your earnings from buying and selling the hat, and then interpret the expression. So our sticky note here says first use a model. The model could be something you already know, and I know that if we have, in this situation, if we sell something, the selling price minus the price we paid would equal the amount of money that we earn. And I know the selling price and the paid price, so that can give me what it is we're trying to sell for. The selling price, according to the problem, was 2D minus $4. We'll subtract the price paid, which was D minus $2, to figure out the earnings. Now we just followed the directions from each of the slides previous. We'll change all the subtraction to add the opposite. I'm going to put a coefficient there, and we'll distribute. Negative 1 times D is negative D, and negative 1 times negative 2 is a positive 2. Find like terms, 2D and negative D, and negative 4 and 2. D plus negative D plus negative 4 plus 2, and then combine like terms. 2D plus negative D is the same thing as saying 2D minus D, so that's just 1D, plus negative 4 plus 2 is negative 2. I know this is exactly the same thing as saying D minus 2. As far as interpreting this expression, we ended up with earnings of D minus 2, which is exactly the same amount that we bought the hat for, D minus $2. So if we earned as much as we paid, we doubled the we doubled our investment in this case. So just to recap, when adding or subtracting linear expressions, first change all of the subtraction to add the opposite. Distribute whenever you have a coefficient out in front of parentheses. Find and combine like terms, and then you are all done.